What is factoring? It's a number or an expression that divides another expression evenly, essentially meaning that you have no remainder. So number 225, its factor is 5. You can divide 225 by 5 and you would get another whole number. Same way we have factors when it comes to algebraic terms and expressions. So if I have 9x squared, I can divide this by 3x. How would that play out? Well, the 9 and the 3 can be divided, and then the x squared would be divided by the x. 9 divided by 3 is 3. X squared divided by the x would leave me with x. Hence, this is a factor of this. Okay. So something that we often need to do is find the greatest common factor of an algebraic expression. What that means is you look at your algebraic expression, you see how many terms you have, you're trying to determine what is an algebraic term that can divide every part of this expression without any remainders. So we're going to go term by term and look at it piece by piece. So I normally focus first on the numerical parts of the term, and then I look at the algebraic parts of the term. So this expression has 2, it has an 8, it has a 2. Okay. So what is a number that can evenly divide both 2 and 8? Well, 2 can divide both of those numbers. There's no number bigger or smaller than that. So we know, okay, whatever my factor is, it must contain 2. Because 2 can divide 2, you would get 1. 8 can be divided by 2, you get 4. Now, let's look at the algebraic variable part. So we have x to the power 4, x to the power 3, and x, which is x to the power 1. Which of these can divide? Well, let's write this out. X to the power 4 is x times x times x times x. X to the power 3 is x times x times x, and x is equal to just x to the power, just 1x. Okay. Notice this x can divide this x, can divide this x. So the smallest or the greatest common factor of x to the power 4, x to the power 3, and x to the power 1 is x to the power 1. Generally speaking, when it comes to finding the greatest common factor of the variable, you choose the variable with the smallest power. So since among these we have x4, x cubed, x1, x to the power 1 should be part of my common factor. Okay, so now that we determine our common factor, how can we use it to simplify our expression? So there's actually a hidden step here. What that hidden step is saying is, okay, I recognize my common factor is 2x. So if I'm taking 2x out, what am I doing? Again, factor means it can evenly divide the term. So I am dividing each of these by my common factor of 2x. And because I'm doing that division, I can write this factor out here as the multiplication that can get distributed. So it's kind of doing a distribution process in the opposite direction. Okay. And then you simplify each of these terms inside the parentheses. Well, this 2 and this 2 divide out. This x to the power 4 divided by x to the power 1 would give you x cubed. The 8 gets divided by the 2, it becomes 4. And then x cubed is getting divided by x, that gives you x squared. 2 gets divided by 2, and then this x gets divided by x, you're left with 1. All right? So this is basically the hidden step. All right, so let's try to factor each of these. Well, again, let's look at the numbers. We have 18 here, and then we have negative 27. So between 18 and 27, both of them can be divided by 3. But the goal is to find the greatest common factor. So let's see if there's a number that's bigger. Both of them can be divided by 9. 18 divided by 9 is 2. And then 27 divided by 9 is 3. And that would be the greatest common factor for those numbers. Now we have x cubed and x squared. So again, when it comes to the variables, just take the variable with the lowest power. So x squared would be my greatest common factor. So now what am I going to do? Well, this is a factor that I want, 9x squared. That means I'm going to write out the hidden step. Normally we don't write it out, but just for completion and understanding, I'm writing it out here. Okay, so then this is what's happening. So then 18x cubed is getting divided by the 9x squared. So that just leaves me with x, because 2x. 18 divided by 9 is 2, x cubed divided by x squared is x. Now 27 divided by 9, that's 3. So x squared divided by x squared, that's 1. So we're just left with 3. And that is this particular expression in factored form. Okay, now let's look at this one. This one looks a little bit complicated because you may be tempted to go ahead and do this multiplication and distribute. But if my goal is to factor, then distributing won't help me because I'm actually going further away from what I want. If I want factored form, factored form results in one algebraic expression being multiplied to another algebraic expression. So again, going back to this previous example, now we have two different things being multiplied, whereas here we had terms being added. Okay. So we don't want to distribute. What we're going to do is, in terms of this plus sign, this is one term, one expression being added to another expression. Within this expression, you have the x squared being multiplied to x plus 3. Same way, you have the 5 being multiplied to the x plus 3. So the x plus 3 is the common factor between the two. So our common factor is x plus 3. So we can take the x plus 3 out. So now, going back to that hidden step, what does that mean? Well, x squared, and we have the x plus 3 being divided by the x plus 3. Plus, we have 5x plus 3 being divided by the x plus 3. Now, when you focus on this fraction, within this fraction, everything in the numerator is being multiplied. Hence, we can actually divide this x plus 3 with this x plus 3. Okay, so the cancellation step is essentially dividing something away. So these two get divided away. And we're just left with x squared. Now looking at this one, same idea. Everything in the numerator, everything in the denominator is in factored form. They're in a form where everything's being multiplied. Hence, this x plus 3 can divide out this x plus 3. So we're left with plus 5. And now this is in complete factored form.